Hi everyone. So now let's get back to the EM waves. In the last lecture we studied about boundary condition. There we studied electric field and magnetic field. So now we will come back to the EM wave part. So the name of the topic is wave reflection. But along with the reflection there will be transmission as well. So this is just the name. So along with the reflection there will be transmission as well. And now we need to study normal incidence. So what do I mean by that? So again, you know, there is some medium 1, there is some medium 2, and in between there will be this boundary. Medium 1 here, medium 2 here. This boundary will be there. So my wave is traveling. Now electric field is not traveling. Neither I can say my magnetic field is traveling. My wave is traveling. That means electric field and magnetic field are dancing and wave is traveling. So wave is traveling in this particular medium. Now it strikes to the boundary. It is incident on the boundary perpendicularly. Basically, this is how my wave is traveling and it is struck on the boundary. So now what will happen? Some part will be transmitted and some part will be reflected back. So this is your incident wave. This is known as incident wave. The wave which is coming from here. This is your incident wave. Now some will be reflected back. So this will be your reflected back. This wave will be reflected back. This is known as reflected wave. And some wave will be transmitted. So this is known as transmitted wave. Okay. So this is your medium 1, this is your medium 2. It is having its own sigma epsilon mu. This is also having its own sigma epsilon mu. Now this wave, this is your incident wave, right? This is your incident wave. So it will have its own neta and beta, neta, alpha and beta. Are you getting this point? Neta depends on mu and epsilon. So for this medium, neta will be different. Do you agree to this point? It will have its own beta. Beta also depend on mu epsilon. So it will have its own beta as well. Alpha also depend on mu and epsilon, because that is the formula. Like for conductor it is, this is the formula. So it depends on sigma, mu and all this point. So this medium will have its own neta, beta and alpha. Do you agree to this point or not? This medium will have its own neta, beta and alpha. So neta, beta and alpha is not associated with medium. This is the property of a wave. So what will be the value of neta, beta, alpha for this particular wave? Can you tell me? Same only, right? Because they are in the same medium. If they are in the same medium, that means their mu and epsilon are same. So for this wave as well, you will have neta, beta and alpha. Okay. But for this wave mu, epsilon and sigma has changed. So this value, neta value will change. This wave will have its own neta. Then beta value will also change. And alpha value will also change, because they are depending on sigma, epsilon and mu. So one medium will have its own sigma, epsilon, mu. Other medium will have its own sigma, epsilon, mu. And the wave which is traveling in this medium, this wave is traveling. There is incident wave as well. There is reflective wave as well. Incident wave is there. Reflected wave is there. So both of the waves will have same neta, beta and alpha. Why is that so? Because they are in the same medium. But this wave is in the different medium. So it will have its own neta, beta and alpha. Is that clear to you? Now let's understand more what do I mean by this boundary and how the waves are being reflected. So let's just say this is my boundary which is z equals to 0. My boundary is z equals to 0. Now my wave is traveling from z less than 0 to z greater than 0. My wave is traveling from z less than 0 to z greater than 0. This is the diagram which is in 2D. This diagram is in 2D. So z equals to 0. My plane is z equals to 0. What do I mean by that? If this is my x, this is my z and this is my y. X, y and z. Which will be my z equals to 0 plane? These we have seen a lot of times, like it should be in your tips that how to draw these diagrams. So this is your z equals to 0 plane, right? This is your z equals to 0 plane. So wave is traveling here. So this is the direction of propagation of wave. Direction of propagation of incident wave. So this is how your wave is traveling. This is the direction of electric field. Now if this is the direction of electric field, where should be the direction of magnetic field? What do you think? Towards u, right? Because E cross H should give you P. So direction of propagation of magnetic field should be towards u. So our electric field is dancing in x direction, our magnetic field is dancing in y direction, and our wave is traveling in z direction. x, y traveling towards z, and now it will be incident on this boundary. So some part will be transmitted. So this is your transmitted part. So what I will tell, look, it was traveling like this, then it was traveling like this, the wave was traveling like this, then it will be transmitted. So the direction of wave will not change. Do you agree to this point? I was traveling like this, then some medium came, some other medium came, so I am going in the same manner only, no? So direction will not change. In this direction I was going, now in this direction only I am going, so direction will not change. For the which wave? For transmitted wave. So this is your transmitted wave. So for transmitted wave, direction did not change. Same direction will be for E and same direction will be for H as well. Just there is a change of medium. Here there was different medium, here there is different medium. The wave was traveling like this only. Then neta value, alpha value, beta value will be different. Neta, alpha, beta value will be different. Sigma, epsilon, mu will be different. So equation here will be different. But I am talking about only direction. So we are traveling like this. So reflected wave will also have the, transmitted wave will also have the same direction. Now let's talk about the reflected wave. So this was my boundary, right? This was my boundary. So wave came and then it is reflected back. So now where the wave will travel, in this direction, the wave will travel. Initially it was coming like this. Then here it struck and now it will travel like this. So the direction of wave got changed, right? This will be the direction of a reflected wave. What I am talking about? Incident, reflected and transmitted. So transmitted wave has the same direction, but reflected wave changed its direction. So initially it was traveling in positive z direction, right? From z less than 0 to z greater than 0 it was going. So it was traveling in positive z direction. And what was the direction of electric field? That was Ax cap. And what was the direction of magnetic field? That was Ay cap. Now it has changed, right? Now it is traveling in minus z direction. Now it is traveling in minus z direction. Now one of the guy has to change their direction, right? Either magnetic field will change its direction or electric field will change its direction, right? Are you agreeing to this point? This was my incident wave. This is my reflected wave. So reflected wave has been opposite. Reflected wave has been opposite. The direction is opposite. So one of the guy has to change its direction. So who will do the sacrifice? So for our assumption, we are saying that electric field is in the same direction only. Electric field did not change the direction. Electric field was dancing in X. Okay. Electric field was having this direction. So here also electric field is having this direction only, but magnetic field is changing its direction. This is our assumption. I am not saying that certainly this will be in the same direction and magnetic field will change the direction. This is our assumption. And why only one guy is changing the direction? If I say that this guy has changed the direction, let's just say this guy is minus X cap and this guy has also changed the direction, this guy is minus Ay cap. So minus minus got cancelled. So what will be the answer of this? Az gap. But what do you need? Minus Az gap. So one of the guy has to change. If I am saying that this guy is not changing, so Ax cross minus Ay, what I will get? Minus Az. So what I am saying, electric field is not changing, but magnetic field is changing. So using this assumption, we will derive the formula. Are you getting this point? So this assumption is very important. What is our assumption? We will write it down. Okay. So what we have assumed, this is not incident, sorry. This is reflected. Really sorry, this is reflected, and this is our reflected magnetic field. Incident electric field, incident magnetic field, incident wave propagation. Reflected, same. In the reflected wave, there is everything same because it just came and then got, sorry, not reflected, transmitted, really sorry. In the transmitted wave, everything was same. It just came and it was transmitted. But for the reflected wave, it was going in this manner. So reflected electric field did not change, but reflected magnetic field got changed. This is our assumption. Is that clear to you? Okay. So assuming reflected E field as the same direction as transmitted, sorry, not transmitted, I should say, as the same direction as incident E field. Is that clear to you? Okay. So we are assuming it is in X direction only. This is also in X direction. This is also in X direction. So reflected wave is not changing. So magnetic field is changing. What I am saying, reflected electric field is not changing, but reflected magnetic field is changing. Okay, so now we will derive the expression. So can you write down the equation of incident wave? Only you need to write down the phasor form as I have written. So incident electric field expression I need to write. So I am assuming that my incident electric field has the magnitude of EIO. Okay, incident electric field has the magnitude of EIO. It was traveling in plus z direction and the direction was plus ax cap. Is that clear to you? I am only writing the phasor form. EIO e to the power minus gamma z ax cap. And what about the incident magnetic field? Incident magnetic field. But here I will write gamma 1. Why gamma 1? Because gamma 1 is equals to alpha 1 plus iota beta 1. Why this 1? Because this is in the medium 1 and this medium 1 is having its own sigma epsilon mu neta alpha beta. Here I have written wave because this is the property of wave, right? This is the property of wave, but these guys are depending on these guys. Is that clear to you? HIO minus same, but the direction was y. Is that clear to you? What about the reflected wave? Reflected wave is in this medium only. Reflected wave is in this medium only. So they will have also gamma, neta and alpha and beta, right? So what about the reflected wave? ERO. Magnitude will be different. Magnitude will not be same. If magnitude is same, then what got transmitted? Like there is something that has been transmitted, right? Everything is not reflected back. So magnitude will be different. So that magnitude I am writing ERO. E to the power minus gamma z, sorry, not minus gamma z, plus gamma z, right? And gamma 1 or gamma 2? Gamma 1, because the medium is same. Reflected wave has this medium only. So for this medium you have gamma 1. Alpha plus iota beta is, or gamma beta is gamma 1. This is your gamma 2. Alpha plus j beta, this is gamma 1, this is gamma 2. So this has, but it is traveling in negative z direction. That's why I am writing plus gamma 1 z. Okay. And what is the direction of electric field? I have said that I have assumed that reflected electric field has the same direction as the incident electric field. So I am saying that it is not changing its direction. And what about this guy? This has also wave traveling which is in minus z direction, but this guy has changed its direction. Magnetic field has changed its direction. Tell me one thing, what will be the HIO value? HIO value will be EIO divided by neta. Neta what I will write? Neta 1. Because we are talking about this medium only. All these guys are in medium 1. So we are talking about medium 1 only. And what will be your HRO? HRO will be ERO divided by neta 1. Is that clear to you? Transmitted wave. Transmitted wave, sorry, here is the transmitted wave. So transmitted wave, which direction it is traveling? It is traveling in AZ cap direction. This was traveling in AZ cap direction only. And this was traveling in minus AZ cap direction. Okay. So let me put in the box as well. Minus AZ cap plus AZ cap and plus AZ cap. What will be its magnitude? ETO. E to the power minus gamma z. Gamma 1 or gamma 2? Gamma 2, because medium got changed. Gamma 2z. And what is the direction of electric field? This did not change. They have the same direction. Right? What will be the difference between these two and these two? The only difference will be this magnitude, nothing else. Because wave was traveling like this only. Some part got reflected back. So that is different. But it is got transmitted. So direction and all, everything is same. So direction and everything will be same only. So ETO, e to the power minus gamma 2z. And what about HTO? HTO will be e to the power minus gamma 2. Why gamma 2? Because medium is different. Minus gamma 2z. What will be the direction? AY cap only. Is that clear to you? So what will be the value of HTO? HTO will be ETO divided by eta 2 or eta 1? Eta 2, because medium is second. Right? So you should have the habit of writing down these things, where your gamma 2 is alpha 2 plus j beta 2. This is your medium 1 and this is your medium 2. Okay. Now we will apply boundary conditions. So boundary conditions, near the boundary I am applying. So near the boundary, tell me what is the total electric field in this direction? Total electric field for z less than 0. Total electric field for z less than 0. That is EIO plus ARO. EIO plus ERO. Is that clear to you? EIO plus ERO. At Z equals to 0. If you put Z equals to 0, what do you get? EIO plus ERO. And both are in AX cap direction. So can I write down in this manner? EIO AX cap plus ERO AY cap. Sorry, AX cap only. Because this is my assumption. What is the assumption? Everything I am writing assuming that direction of reflected E is equals to the direction of incident E. Okay, this line is very important, very important, because it's not necessary that always magnetic field will change. When we solve the problem, it will be more clear to you. So here only for the derivation purpose, only like very small derivation we are going to see. Only for the formula purpose we are doing this all these things. Rest all the things we will understand when we do that problem. So in this particular lecture, problem solving is very important. So this is one of the topic where you will get your answers wrong if you don't solve the problem in a good manner. So that I will tell you, once we derive some formula here, only one formula we will derive. Only one formula we will derive, and based on that we will solve all the problem. Okay, so what we are doing, we are applying the boundary condition. And at this side, what is the scene? Along this side, this was medium 1, this is medium 2. So along medium 2, what is the scene? ERO AX cap. ETO AX cap, transmitted wave, ETO AX cap. Incident, reflected, and towards the other side of boundary, ETO AX cap. Right? So AX cap is getting cancelled. So what you are getting? EIO plus ERO is equals to ETO. This is your equation 1. You can apply magnetic boundary condition as well. What does the magnetic boundary condition say? The tangential component of magnetic field is continuous. Tangential component of magnetic field is continuous. Tangential component of electric field intensity is continuous, and tangential component of magnetic field intensity is continuous. If you remember this thing, ET1 is equals to ET2 and HT1 is equals to HT2. This was given when this is always true, but this is true when K is equals to 0. So certainly here K is 0. There is no surface current density. Certainly there is no surface current density. Here there is no surface current density. So you can apply this. Now you can apply the magnetic boundary condition. So how do I apply the magnetic boundary condition? So I need to see the tangential component across this boundary. So what is the tangential component of a magnetic field? What is that tangential component of magnetic field? This one, which is, this is your HI naught AY cap. So what I can do, HI naught AY cap. And what about the reflected one? HR naught AY cap, but minus sign is there. So minus HR naught AY cap. What about the transmitted one? Transmitted one is HTO AY cap. HTO AY cap. Is that clear to you? Basically, towards this side of boundary, you are having this magnetic field and this magnetic field. So HIO minus HRO is equals to HTO. Because HIO and HTO are having the same direction. HRO is opposite. HIO, HTO. HRO is opposite. So HIO minus HRO is equals to HTO. This is what we are getting. HIO minus HRO is equals to HTO. Okay. Can you write it down in this manner? EIO divided by eta 1 minus ERO divided by eta 1 is equals to ETO divided by eta 2. From here I got this formula, right? They are in the same medium, so in eta 1, and this is having opposite medium, so eta 2. So this is your equation. Let's not call it equation 2. Let's call this as equation 2. EIO minus ERO is equals to eta 1 by eta 2 ETO. Is that clear to you? Okay. So what I am doing now, I can add both of the equation 1 and 2. So can you solve these equations, right? EIO, ERO, ETO. Can you solve these equations? If you add both of them, what you are going to get? 2 EIO is equals to ERO will get cancelled. 2 EIO is equals to eta 2 plus eta 1, and downward you will be having eta 2 is equals to ETO. So ETO divided by EIO is equals to 2 eta 2 eta 1 plus eta 2. So this ratio we have got ETO divided by EIO. This is known as transmission coefficient. Okay, you don't need to remember it, but transmission coefficient of electric field, because what we have assumed here, I will write tau E. We are solving all the numerical, converting it into electric field. I did not give this as equation 2. No, we have assumed everything in terms of electric field. Also we have assumed that electric field is not changing its direction. What we have assumed, the electric field is not changing its direction. This was incident, transmitted and reflected. Electric field is same. So I am calling it tau E, transmission coefficient. Transmission coefficient for electric field. Okay. Now in this particular, or what do I do? Okay, if I pick equation 1, what is my equation 1? EIO plus E reflected. Like this is very simple derivation which you can do, divided by ETO. And if I divide EIO on both of the sides, so what I will get? 1 plus ERO divided by EIO is equals to ETO divided by EIO. Okay, so from this what I am gonna get? ERO divided by EIO. What is this value? That is 2 eta 2 divided by eta 1 plus eta 2 minus 1. So if you solve it, what you are going to get? ERO divided by EIO is equals to eta 2 minus eta 1 divided by eta 2 plus eta 1. Okay, let's write it better. Eta 2 minus eta 1 divided by eta 2 plus eta 1. So here also I will write down in this manner only, eta 2 plus eta 1. So this is known as reflection coefficient. What it is known as? Reflection coefficient. Reflection coefficient. For E field. Okay. And if you see both of the formula very carefully, what do you understand? This was your gamma E, this was your tau E, and this was minus 1. So this was your gamma E, this was your tau E, and this was minus 1. So what do you get? Tau E is equals to gamma E plus 1. So 1 plus gamma E is equals to tau E. So which formula you will remember? Which formula you will remember? This one and this one. Only these two formula you will remember. And one more thing you will remember. What is that? That you have derived these expression assuming that electric field is not changing its direction. Is that clear to you? You have derived this expression assuming that electric field is not changing its direction. Okay. So let me add a page. So let's write down all the formula which we have got. Eta 2 minus eta 1 divided by eta 2 plus eta 1, and 1 plus gamma is equals to tau E. Gamma is the reflection coefficient, tau is the transmission coefficient. Okay. Now one thing, can you let me know what will be the range of gamma E? From where to where gamma E can have the values? Can you let me know this thing? Minus 1 to 1. Why is that so? Can I write it down in this manner? 1 plus neta 1 by neta 2. You think of any value, you think neta 2 by neta 1 is 1. Neta 1 by neta 2 is 1. So what will be the answer? 0. I am talking about gamma E. What is the range of gamma E? This is what I am talking about. That means what values it can take. The worst way could be that this is 0. Neta 1 by neta 2 is 0. So what will you will get? 1. So this is the maximum value it can get. And what will be the minimum value it can get? That this value is very, very high. That means neta 1 by neta 2 is tending to infinity. If that is tending to infinity, that means 1 can be eradicated, like 1 can be ignored. So neta 1 divided by neta 2 divided by neta 1 divided by neta 2, and minus sign is there. So what will be that answer? Minus 1. So it can have the value from minus 1 to 1. You see this expression, no? A minus b upon a plus b. What is the range of this particular number? Minus 1 to 1. This cannot be bigger than minus 1. Sorry, this cannot be bigger than 1, and this cannot be less than minus 1. So the range of this particular expression is minus 1 to 1. Right? So very simple thing, just basic mathematics it is. But and if I ask you what is the range of mode of gamma e, then what you will say? What is the range of mode of gamma e? Mode, that means all negative value will be made positive. So that will be from 0 to 1. Right? If gamma e you are getting minus 1 by 3. Gamma e you are getting minus 1 by 3. So what will be its mode? 1 by 3 only, no? So from 0 to 1. So the range of mode of gamma is 0 to 1. These kind of questions are asked in one liner. That what is the range of reflection coefficient? Sorry, magnitude of reflection coefficient, that is 0 to 1. And what is the range of reflection coefficient? That is minus 1 to 1. Also you can understand that that we will see later on. That analogy we will see later on. Otherwise you will get confused here. Okay. Now what should be the range of tau e? That you should be able to tell on your own. Otherwise you need to study mathematics. What should be the range of tau e? Least value of gamma is minus 1. So 1 minus 1, 0. And maximum value of gamma is 1. So 1 plus 1, 2. So the range of tau e is from 0 to 2. So one liner question these are. Okay. Range of gamma e from minus 1 to 1. Magnitude of gamma is from 0 to 1. Range of tau is from 0 to 2. So what did you get? ERO divided by EIO. Reflected by incident. Incident reflected. That is known as gamma e. So from here what are you getting? ERO is equals to gamma EIO. So if I write down that my EIS is equals to EIO e to the power minus gamma z EX cap. So can I write down my ERS? Reflected wave is gamma E EIO e to the power plus gamma z EX cap. Is that clear to you? Considering x is not the direction of electric field is not changing. Is that clear to you? This is my EIS. This is my EIS. EIO e to the power minus gamma 1 z actually. Gamma 1 z. We are talking about medium 1. Gamma 1 z and AX cap. And this is your reflected wave. Reflected wave was ERO e to the power minus gamma 1 z AX cap. So in place of ERO, I have put gamma E EIO. Okay. Gamma E EIO. So this will be the expression of reflected wave. Is that clear to you? What else you know? That your E transmitted divided by E incident. Charger one है क्या? Charger one है. Is equals to tau E. For tau what you will calculate? First you will calculate the reflection coefficient, then you will do 1 plus, then you will get tau E. So this is what we know. Transmission by incident. Transmission by incident is tau E. So from here what you can write? ETO. ETO is equals to tau E EIO. ETO is equals to tau E EIO. Right? So now you let me know one thing. What will be the expression of ETO? Sorry, ETS. You need to write down the phasor form of transmitted electric field. Phasor form of transmitted electric field. That is ETO e to the power minus gamma 2 z AX cap. So what I'm gonna write here? In place of ETO, what I'm gonna write? Tau E EIO e to the power minus gamma 2 z, because this is in the medium 2 AX cap. Is that clear to you? Now from these expressions, using these expression, can I write down the value of HIS and HRS? Yes. I am not learning any formula for magnetic field. All these formulas I have studied for electric field. If I have the expression of electric field, can I get the magnetic field? Yes. And if I have the transmission electric field, then can I get the transmission magnetic field? Transmitted magnetic field. Certainly you can get. So always keep in mind that you remember the formula, that is neta 2 minus neta 1 divided by neta 2 plus neta 1. That is for the electric field transmission coefficient. The formula that I remember, that is for electric field transmission, not transmission, sorry, electric field reflection coefficient. Okay, reflection coefficient electric field. This formula I remember. So always any expression is given, my first task would be to convert it into electric field. If magnetic field is given, so my first task will be to convert it into electric field and then solve the problem. If EIS is given, sorry, if HIS is given, what I will calculate? EIS. Then from that I will calculate ERS. Then from that I will calculate ETS. From ERS I can get HRS. From ETS I can get HTS. All these will be clear when we solve the problem. So as of now, what you need to remember? Only these two things you need to remember. That's it. Okay. And these things also you should keep in mind, that your reflected wave has the magnitude. Your reflected wave has the magnitude of gamma E EIO, and your transmitted wave has the magnitude of tau E EIO. Is that clear to you? Okay. Only these things you need to keep in mind. We will solve the problem. It will come to you that what I am talking about. Okay. Everything you will understand, and assumption also you need to understand. Assumption also you need to remember. What is the assumption? That electric field is not changing its direction. That is the assumption we have made. Okay. Yeah, one more note is there, you can say. So incident EM wave. So this was your boundary. So this was your incident EM wave. So this will carry some power with it. Incident EM wave, not electric wave, sorry. Incident EM wave will carry some power. Some part will be transmitted and some part will be reflected back. So this will be your incident power, because what is your EIS? EIS is EIO e to the power minus gamma Z EX cap. You would say that, sir, this is not the complete power, you should write minus 2 alpha Z cos theta n. You are actually correct. This is how I should have written it. Okay, there is no doubt about that. But okay, let's write it in this manner only. EIO whole square divided by 2 eta n e to the power minus 2 alpha 1 Z cos theta neta 1 है. Okay, e to the power minus 2 alpha 1 Z cos theta neta 1. Is that clear to you? So what will be your reflected power? Reflected power you need to tell. So in reflected wave, what is the scene? ERS. In reflected wave, this will become your gamma E EIO. Do you agree to this point? Gamma E EIO. E to the power minus gamma Z, gamma 1 EX cap. Is that clear to you? So can I write here gamma E EIO whole square? Neta will be same for both of them. 2 alpha 1 Z cos theta neta 1. Nothing will be changed. Alpha will not change, neta will also not change, because the medium is same. So what do you understand here? That your reflected wave power, can I take gamma E whole square take outward? Gamma E whole square can I take outward? Say yes or no? Yes. So mode of gamma E whole square incident power. So this is the formula. This is the formula of reflected power. Is that clear to you? Gamma E I took outside. Now this gamma E could be complex as well. That's why I am putting magnitude. This gamma E could be complex as well, right? Gamma is neta 2 minus neta 1 divided by neta 2 plus neta 1. This is your gamma E. Neta 2 minus neta 1 divided by neta 2 plus neta 1. This could be complex, no? Neta. If you remember, neta has some angle, theta neta 2. So this could be complex. So that's why I am writing down the magnitude. So this is the formula you need to remember. Can you keep this in mind? That your reflected wave will have the power multiplied with gamma E square. One thing I know, that whatever the power I had, initial power that I had, some power got transmitted and some power got reflected. Is that clear to you? Right? Some part got transmitted, some part got reflected. This part got transmitted, this part got reflected, right? So this is Pi, this is transmitted, this is your reflected. How much power part is reflected? This much is reflected. So what you are getting? Transmitted power is 1 minus gamma E square P incidence. This is your transmitted part. Is that clear to you? Two formula, very easily you will be able to keep in mind. Okay, very easily. So let's see till now what we have discussed. So till now we studied what is your normal incidence, right? Incident wave was there, then reflected wave was there, and then transmitted wave was there. Why do I call it normal incidence? Because this is my plane, and my wave is incident like this. This is my wave which is incident like this. This is my plane. Okay, if it was incident like this, then it would be oblique incident, but it is being incident like this. So this is called normal incidence. So this is your normal incident. Now for deriving the expression, what I am assuming that electric field is in the same direction. For reflected wave, our wave direction will change. For reflected wave, our wave direction will change, but I am assuming that my electric field is in the same direction. So magnetic field has to change its direction. Initially it was in this direction, now it is in this direction towards, sorry, initially it was towards us, now it is being opposite. And transmitted wave will be exactly same. It is traveling in plus z, it will travel in plus z only, electric field in plus x, magnetic field is plus y. Is that clear? Then we derived this expression, very easily we got the expression. This is the incident wave, reflected wave and transmitted wave we have written, and we have written the corresponding HIO, HRO and HTO value as well. Magnetic field amplitude we have written. Okay. So EIO plus ERO is equals to ETO by applying the boundary condition. We are applying the boundary condition because tangential component we know that will be equal. So tangential component EIO plus ERO is equals to ETO. And what about H? H is changing its direction. So HIO minus HRO is equals to HTO. So from there we got this expression, tau E and gamma E. What is gamma E? Gamma is the reflection coefficient and tau is the transmission coefficient. How will you remember tau T? Tau and T. Tau is the transmission coefficient. The transmission coefficient of E field, this is the reflection coefficient of E field. So what did I ask you to remember? Neta 2 minus neta 1 divided by neta 2 plus neta 1 is the reflection coefficient. This is the reflection coefficient. And what is the formula for transmission coefficient? That is 1 plus tau is equals 1 plus gamma is equals to tau E. 1 plus gamma E is equals to tau E. That is your transmission coefficient. Is that clear to you? Yes. So from there we got to know that my gamma E can take value from minus 1 to 1 and tau E can take value from 0 to 2 and magnitude of gamma E can take value from 0 to 1. And my reflected wave is equals to, my reflected wave has an amplitude of gamma E EIU and my transmitted wave will have an amplitude of tau E EIU, right? So in the question first I will find the gamma and then I will find the tau and I can write down the expression of ERS and ETS. From EIS I can write down the expression of ERS and ETS and from there I can get HTS, HIS and HRS. So always in the problem I will solve by electric field. First I will find the electric field, then I will get the expression and then I will find out my final answer. Okay, why I am not teaching you the expression of magnetic field, you will understand when we solve the problem. So this is only the discussion part which I am telling as a conclusion. The main part will start when we solve the problems. So in problems you will get a lot of new things. Okay, so there you will understand a lot of new things. And one more concept we studied, but first let's delete this page which I will delete later on. First let's blacken it. So that page I will delete later on. One more note, what did we show? That incident power is Pi, then reflected power will be mode of gamma E square Pi. Reflected power will be mode of gamma E square Pi. And what will be my transmitted power? That would be 1 minus gamma E square Pi. Reflected will be gamma E square Pi and transmitted will be 1 minus gamma E square Pi. Very easily you will be able to remember it. Let's solve the problem and do not skip the problems. Like here only you will be learning the true concept. Let me tell you, here only you will be learning the true concept. Okay. So Hi is given. Incident magnetic field is given in free space. So in this free space, it will have sigma equals to 0. It will have epsilon 1 I will call it is equals to epsilon naught. Mu 1 is equals to mu naught. Right? What will be its eta? 120 pi. What will be its alpha? 0. What will be its beta? Beta will be omega by c. Beta 1 will be omega by c. 10 to the power 8 divided by 3 into 10 to the power 8. So that will be 1 by 3 radian per meter. Is that clear to you? All these things are clear to it. Is incident normally on lossless medium? Lossless. So sigma is 0. Epsilon 2 is equals to 2 epsilon naught. Mu 2 is equals to 8 mu naught. This example is from Sadiku, okay. Again, the next example is framed by me, but this is the example from Sadiku. Next will be mine only. And this is the region which is z less than 0, and this is the region for z greater than 0. So yeah, what will be its neta? 120 pi. I hope you remember these formulas now, right? Mu r epsilon r. So 8 by 2, 4, 2. So 240 pi. Ohm. Certainly all are ohm. And what will be its alpha? Certainly 0. And what will be its beta? Beta will be omega by c under root. Like what is the actual formula? Omega under root mu epsilon. So what it will be? Omega by c under root mu r epsilon r. What is the value of omega by c? Look, omega will never change, okay? Omega will never change. The wave will travel with the same omega. The frequency will always be same. What I am writing? Omega will always be same. You can star mark it. The frequency will never change. Yeah. So what you are going to get? 1 by 3. Omega by c value is 1 by 3. Under root 8 into 16. That would be 4. Right? So under root 2 into 8. So from here what you are getting? Your beta, not beta 1, these are 2, sorry, all these are 2, beta 2. Your beta 2 is in 4 by 3. Unit you can write down radian per meter. So these are the values. Every time in the examination we are not going to find these values, but this is since the first question, that's why I am telling it. So are you going to solve with the HI? Are you going to solve with magnetic field? No, I am going to solve with electric field. So first I will always solve with the expression of electric field. So HI is given, which is equals to tan cos 10 to the power 80 minus what will I write? Beta z or beta 1 z? Beta 1 z. Here they will give beta z, but this is my medium 1, so I will write beta 1 z here. Beta 1 z Ex cap. So these small things I will take care. Okay. Forget about the unit, whatever it is. From this magnetic field expression, I need to find electric field expression now. So how will I find that? Tan into eta 1. Why is that so? Because EIO is equals to eta 1 HIO, right? Neta is equals to E by H. So from there EIO is equals to neta 1 HIO. Very easy. So tan into neta 1. Why neta 1? Because let's make the medium here as well. In the examination you wouldn't have to make, but here I am making. Because in this medium, in medium 1, this is your medium 2. In medium 1 there will be EI, there will be HI, there will be E reflected, there will be H reflected, and here there will be E transmitted, and here there will be H transmitted. So this kind of diagram you can make in your examination as well. Here you can write down neta 1, beta 1 and alpha 1, and here you can write down neta 2, beta 2 and alpha 2. Okay. So then you will not be confused that whether I should use neta 1 or neta 2. Should I use beta 1 or beta 2? Should I use alpha 1 or alpha 2? So since you are in medium 1, so I will use neta 1 here. Cos omega t, wave is propagating in plus z only. What will be the direction of electric field? Minus Ay cap, right? How did I write that? What do I know? That E is equals to, P is equals to E cross H, right? So if I need the direction of E, so what that would be? Ae cap is equals to AH cross AP. So what is my AH? AX cross AZ, what that would be? Minus AY. So in that manner I can write down. Okay. So this I have found EI, incident electric field. So I will solve all the problem corresponding to incident electric field, because I know the formula for electric field only, right? I know the formula. Which formula I know? That reflected wave. In the reflected wave, what will be my magnitude? ERO divided by EIO, which is known as gamma E, which is equals to neta 2 minus neta 1 divided by neta 2 plus neta 1. So this is what I will do. Always I will have EI, always I will have EI, then I will find ER, then I will find ET. With respect to that, I can find HR and HT. Okay. So neta 2 is 240. So 240 pi minus 120 pi divided by 240 pi plus 120 pi. So 120 pi divided by 360 pi, that would be equals to 1 by 3. So your gamma E is coming out to be 1 by 3, right? Very important result. Very important result. Okay. So what will be the magnitude of reflected wave? Magnitude of reflected electric field. Only the magnitude. What that would be? 1 by 3 into EIO. And what is your EIO? That is tan eta 1. So that will be the magnitude of the reflected wave. So only magnitude I have written. Here I will write ER now. So what I need to do? Tan by 3 into neta 1. That's it. Basically, this will be multiplied with 1 by 3, nothing else. I do not even need to write down this line. You will get confused. So what I need to do? Basically, I need to multiply this particular expression with 1 by 3. So what I will get? ER. That would be tan into neta 1, which was already there. So can I put the value of neta 1? That is 120 pi. So let's put the value of neta 1. That is 120 pi into 1 by 3 cos omega t minus beta z or plus beta z? Plus beta z, because it is a reflected wave. The wave, this was incident, this is the reflected. So it is traveling in minus z direction. So plus beta z. Will I change the direction? No, I will not change the direction. Why is that so? Because gamma is equals to 1 by 3. So I am not going to change any direction. Gamma will take care. If gamma will become negative, then direction will change by its own. So I do not change that. I do not need to change the direction. From here to here I am going. What did I tell you in the previous slide? In this slide, from EIS to ERS you are going. So what you are going to do? Only you need to multiply with gamma E. That's it. You are not changing the direction. You do not need to care about the direction. Gamma E will take care everything. We will solve one more question. There it will become more clear. So gamma E will take care everything. From EIS I am writing ERS. Is that clear to you? So direction will be same. Just this will change. That from minus Z to plus Z it will be, because incident was traveling in plus direction. So this is traveling in minus Z direction. So that will change only. So that I have to do on my own. This I will do on my own. And here beta 1 will come because we are running in medium 1 only. But this direction I do not need to change, because gamma will take care. Gamma is becoming positive. What does that mean? That our assumption that incident and reflected wave will have the same direction, that is correct. Our assumption that incident and reflective electric field is having the same direction, that is correct. Because this is what we assumed. When we derived the expression of gamma E, what did we assume? That our incident and reflected wave, in the incident and reflected wave, electric field will have the same direction. And gamma E became positive. So if gamma E would have become negative, then this negative and negative would get cancel out. If that was negative, so here minus sign would come. So this minus and this minus would cancel out. That means your direction of electric field has changed. You assume the direction of electric field did not change, but actually it has changed. So gamma will take care of that. So this is how we will solve the problem. In the examination, a lot of people mess up because they remember a lot of formula. No, I do not need to remember any formula. I know only one formula, that is gamma E, which is equals to 1 by 3 is coming. So from incident to reflected if I am doing, so I will just multiply with 1 by 3. That's it. Nothing else. And one thing I know, that wave direction is changing. The propagation of wave was, if this was plus Z, so now it is minus Z. So that I will change. Nothing else I will change. This minus AY directly I will copy here. Now from here to I will go to HR. From HI to HR I will not go. No. From HI to HR I do not have any formula. I have the formula of EI to ER. From HI to HR I do not have any formula. But from ER to HR I can go. How I can go? From ER to HR. From any electric field can you go to the magnetic field? Yes. So how will I write down HR? What will be my HR? That would be, let's write it down on the next page only. If I have any electric field expression, this is my electric field expression, that is 10 by 3 into 120 pi cos omega t plus beta 1 z minus ay cap. Now I just give you this question, that this is your electric field expression. You need to write down the magnetic field expression. Can you do it? Yes. We have solved these kind of problems. How do we do it? We will divide this by neta, right? And which neta I will divide with? Neta 1. Why is that so? Why I am dividing with neta 1? Because we are in medium 1. If we were in medium 2, I would have divided by neta 2. So what I am doing here is that my HRO is equals to ERO divided by neta 1. So this divided by neta 1, and then this will be copied as it is because wave is propagating in minus z direction. Now how will I write down the direction of H? So what do I know? P is equals to E cross H. P is equals to E cross H. So without even any formula, I am writing down the direction of H now. So what will be my AH? AH will be AP cross AE. What is my AP? AP is minus AZ cap. And what is my AE? Minus AY cap. So Z cross Y will give me minus AX cap. Minus AX cap. Okay. So this is the ER and HR form, ER and HR expression you are getting. So what are you seeing here? That incident electric field was in minus AY direction. Reflected electric field is also in minus AY direction. One thing is for sure that your propagation direction will change. One thing is for sure that your propagation direction will change. That means initially you were going in plus z direction, now you are going in minus z direction. Now you got to know that propagation direction have been changed, but electric field is in the same direction. Initially electric field was in this direction. This is your reflected electric field. This is in the same direction, but propagation direction has changed now. Propagation direction has changed. So who has to sacrifice? Magnetic field has to sacrifice. So magnetic field will change its direction. So now your magnetic field is in minus AX cap. Previously it was in plus AX cap. So one of the guy has to sacrifice, and that will be decided by this particular expression. If this was negative, then electric field would have sacrificed. That electric field will change the direction. And if electric field changes the direction, then magnetic field do not need to change the direction. So just by looking at the gamma E value, will you be able to comment that who will change the direction? Yes. Are you understanding this point? Slowly you will understand. One more example we will see, it will be more clear to you. Okay. So in that manner we will proceed in the problems. If you just go by the method that I am telling, you will not mess up in the examination. Otherwise you will certainly do the mistake in sign. Like certainly you will put wrong direction. If you go on remembering more formulas and without even developing a problem solving method, if you solve these kind of problems, you always do minor mistake. So this is the way you need to proceed. Is that clear to you? Okay. And if I need to find E transmitted, so for that what is the formula I am having? That my tau E is equals to 1 plus gamma E. So gamma E is 1 by 3. Is that clear? So what will be my E reflected transmitted? So 4 by 3 of this expression. 4 by 3 of this expression. So 4 by 3 into 10 into 120 pi. Now you tell me cos omega will never change. In which direction the wave is going? Plus z only. So minus beta z. Which beta I will put? Beta 1 or beta 2? Beta 2. Why is that so? Because now we are in medium 2. So beta 2. So if you solve in this manner, you will never mess up your beta value, you will never mess up your alpha value, you will never mess up your neta. There will be no confusion in the direction as well. Now tell me one thing. If this wave was in minus AY cap, if electric field was in minus AY cap, so reflected wave will have the same direction. That is very simple. This we have already seen. Sorry, not reflected, transmitted. So this was the electric field of incident wave, and this is the electric field of transmitted wave. So electric field of incident wave and electric field of transmitted wave will have the same direction. Magnetic field of incident wave and magnetic field of transmitted wave will also have the same direction. So in the transmission, there is no change in the direction. In the transmission, what will be the change? Change will be this beta value. Okay. So only change will be this beta value. So what will be the direction? Minus AY cap. Now if I need to go from here to here, from here to what? ET to HT. Can I go? Yes. How will I go? 4 by 3 into 10 into 120 pi divided by neta I need to do. So which neta I will put? Neta 2. Why neta 2? Because what will be your ETO? Sorry, HTO. What will be your HTO? That will be ETO divided by neta 2. Why is that neta 2? Because now we are running in medium 2. So in this medium, I need to go from ET to HT. In the medium 2, I need to go from ET to HT. So neta value I will use of medium 2 only, no? Now you will say, sir, why you have used 120 pi here? Because this I did not use. This came from here. Are you getting this point? This neta 1, that is 120 pi, that is coming from the previous expression. I just multiplied 4 by 3 to this expression. This expression was tan into 120 pi already. So this neta 1 came from the previous expression. I did not use it. Here what I used, only 4 by 3. That's it. So now this much value I am already having. That is ETO. If I need to find HTO, that would be ETO by neta 2. So ETO by neta 2, that's it. And what is my neta 2? Neta 2 is 240 pi. Cos omega t minus beta 2z. Will the direction of a magnetic field change? No. That will have the same direction. So these small thing you need to take care and always solve in the method that I have told you. Always start with EI. Just get EI, you can get ER. If you have ER, you can get HR. If you have EI, then you can calculate the ET as well. And if you have the ET, you can find HT as well. That's it. So never ever try to go from HI to HT. Now, HI to EI, EI to ER, ER to HR. That would be the best type, and you will never mess up any of the problem. Otherwise, this topic become very complex and a lot of students do the minor mistake. But we will not do the minor mistake. We will solve in a certain manner. Okay. Yeah. So, and one more mistake I did here in this particular analysis that I just noticed a few minutes back. What is that? That I told you this is your power. No, this is not your power. This is your time average Poynting vector. This is your power density, right? What is this? This formula E naught square upon 2 neta e to the power minus 2 alpha z cos theta n. What it was? Power or power density? It was power density, P average. It was power density, right? What it was? P average. Or what did we call it? What was the other name? Time average Poynting vector. Time average Poynting vector. So that was the other name. So from here, if I need to calculate the power, what I need to do? P average dot ds. So whether I need to take open integral or close the integral, that will depend on the surface. But dot ds I need to do, that will be my total power. So this is my time average Poynting vector, not the complete power. Okay. So I did this mistake. So here I should have told it. So all these are time average Poynting vector. All these are time average Poynting vector. Time average Poynting vector. What is this? Time average Poynting vector. Okay. So in this question as well, what is asked to find? Time average Poynting vector. Pi, PR and PT. So can you let me know what will be my Pi? Pi. That will be E naught square upon 2 neta 1. E naught square upon 2 neta 1, right? So E I naught square upon, and in which medium your wave is running? In medium 1. What will be the direction? Plus AZ gap. Why AZ gap? Because the direction of time average Poynting vector is in the direction of your wave propagation. So wave is propagating in plus AZ direction, so it will be plus AZ gap. Is that clear to you? Okay. So what is my EIO? So that values you can put tan into neta 1 square divided by 2 neta 1 EZ gap. Okay. Now let's find P reflected. So first let's find it directly, like from this expression. From this expression. If I find it directly from this expression, then what will be my answer? This I am putting as neta 1 only. Okay. So E naught square divided by 2 neta 1. Is that clear? This will be my answer. E naught square divided by 2 neta 1. And what will be the direction? Minus AZ gap. Why minus AZ gap? Because wave is propagating in minus z direction. Wave is propagating in minus z direction, and this will always point. Time average Poynting vector always points towards the direction of wave propagation. So minus AZ gap. Is that clear? E naught square upon 2 neta. And which formula I taught? This is without formula. Method 1 I can say, and method 2 what that would be? One formula I taught you, right? Gamma E square Pi. What is my gamma E? 1 by 3 square. 1 by 3 square into what is my pi, that is tan into neta 1, tan into neta 1 square upon 2 neta 1. Okay. Certainly direction will change, right? Direction will change. Direction will certainly be minus az cap. Like you cannot copy the direction from here. That sir, this will be az cap, so here also I will copy az cap. No, direction will be in the direction of wave propagation. So minus az cap will come in action, right? Now is this the same thing? 1 by 3 square tan neta 1 square. So 1 by 3 I can take inside. So that is the same thing only. So tan by 3 neta 1 square, neta not neta I, neta 1 square divided by 2 neta 1. So that is the same thing. Say yes or no, right? Same answer you are getting. Just I wanted to prove that whatever the formula that we have studied, that is correct. That is not wrong. Okay. Yeah, sorry for the interruption. So if I need to write down that transmitted power, so how will I write down? Not power, it is power density, or you can say time average pointing vector. So if I need to write down, how will I write down? So this is the method 1 where I will not apply any formula. I will simply see it from here. That is E naught square by 2 eta. So 4 by 3 into 10 into your eta 1. It was eta 1, right? It was eta 1 whole square divided by 2. What I will write? 2 neta 2. Why neta 2? Because this is medium 2. Now we are in the medium 2. So this neta 1 came from this particular expression. This neta 1 came from here. But now we are in medium 2. So E naught square, this is my E naught square. This is my E naught square divided by neta of this medium 2. Divided by neta 2. Is that clear to you? Right? And direction will be az cap. So what you will get from here, if I simplify it, so 1600 by 9 into 1 by 2 into eta 1 square by eta 2. So eta 1 by eta 2 is 1 by 2 only. Basically this can be written as eta 1 by eta 2 into eta 1, right? This is your 40 by 3. So 40 whole square of 40 is 1600 divided by 9 eta 1 square. This 2 is there, so that is 1 by 2 eta 1 square divided by eta. So eta 1 by eta 2 into eta 1. What is eta 1 by eta 2? 1 by 2, because eta 1 is 120 pi and eta 2 is 240 pi, right? Here we have seen 120 pi and 240 pi. So that would be 1 by 2. So this would be 1 by 2. So this will eventually become 1 by 4. And if this is becoming 1 by 4, so this will become 400. So 400 by 9. And certainly there was neta 1 also present. So this is what you are getting. This is your P transmitted. 400 by 9 eta 1. Okay. Now I need to apply the formula. So what is the formula? That is 1 minus gamma square Pi. Right. So what is gamma square? Gamma square is 1 by 9. So it will be 8 by 9 of Pi. Right. So 8 by 9 of Pi. This is your Pi. Can I improve it? 100 into eta 1 square divided by 2 eta 1 az cap. What you are getting? 50 eta 1 az cap. 50 eta 1 az cap. So into 50 eta 1 az cap. What you are getting? 400 by 9. 400 by 9 az cap. 400 by 9 eta 1 az cap. So this is your time average pointing vector for transmitted wave. Both are similar only. So we will apply the formula in the examination, right? We will just find the value of gamma and we will find out the value of Pi as well. Then we will just apply this formula. So just here also I have proved that our formula was correct only. But in the examination, if they are only asking the time average pointing vector, then I will apply this formula. What is that? This is the formula. That reflected wave will be the gamma square times of Pi and transmitted wave will be 1 minus gamma square of Pi. Is that clear to you? Everything is crystal clear? Okay. So this example was clear to you. So let's revise this example. What did we study? So first we wrote down HI was there. So first we wrote down these values which you do not need to write in the examination. So from HI to EI we wrote. Very simple. So directly we will never solve HI. First we will convert it into EI. So from EI to ER we got. For that we calculated the reflection coefficient. The reflection coefficient we calculated. Then 1 by 3 by that we multiplied, and then we got to know that electric field is not changing its direction. Then from ER to HR we got. Now from EI to ET also we can write down. So for that we need transmission coefficient, that is our 4 by 3. So 4 by 3 I wrote. So this is how we wrote it down, and then HT we could write down from ET. Then we need to find out the time average pointing vector. For that we find out the time average pointing vector by two things. First one is directly by the expression, and then other one was by applying the formula. So from now onwards we will apply the formula. What is the formula? Reflected wave will be gamma square times of incident wave, and transmitted wave will be 1 minus gamma square times of incident wave. Is that clear? Let's move to the next question. Exactly ditto same question. What has changed? This thing has changed. Only this has changed. Okay. Exactly ditto, everything is crystal clear, like everything is same only. All the things you need to find same thing. Just something that is changed is epsilon has changed. So this is our medium one, which is where epsilon is equals to epsilon naught, mu is equals to mu naught, sigma is equals to 0 only. Here also sigma is also 0. Sigma is also 0. This I will call epsilon 1, mu 1, sigma 2 is 0. Epsilon 1 is equals to 8 epsilon naught, and here this is epsilon 2. Mu 2 is equals to mu naught. So let's not write down all the values. Whatever that we need, that we can write down. Certainly we will need the value of neta. So what will be neta? Neta will be, here it will be 120 pi because this is your free space. And what will be neta here? That would be 120 pi under root mu r by epsilon r. Mu r is 1 only. Epsilon r is 8. Okay. That will come in under root. So under root, like needlessly the calculation will be complex. So let's make it 4. Really sorry if you had solved this question using it 8, then you would get different answer now. Just for making the calculation easier, I am making it 4. Okay. So really sorry for this thing. Like if you had solved it using 8, then you will have to change your answer now. But that would make our complex calculation a bit complex. This is just I put some random value. I just want to show you that gamma can be negative as well, and if it is negative, then what all changes will be there. That I want to show. So for that I would try to take easier example. So please do not mind that I changed this value, okay? And please do not dislike the video as well. Yeah, so beta 1 value also I can find. So here it will be omega by c. So 10 to the power 8 divided by 3 into 10 to the power 8. That would be 1 by 3 radian per meter. And what about beta 2? Beta 2 would be omega by c under root mu r epsilon r. Mu r epsilon r. So that would be twice of this. So 2 by 3 radian per meter. Is that okay to you? Okay. Now HI expression I have. So first what expression I will write? First I will write down the expression of EI. So HI expression I am having tan cos omega t minus beta 1z. In which direction? Ax cap direction, right? Now if I need to write down the EI expression, then what I will write down? Tan into neta 1 cos omega t minus beta 1z, and what will be the direction? Minus a by cap. So from HI to EI I can easily write down. Now let's find out the reflection coefficient. So that is neta 2 minus neta 1, that is 60 pi minus 120 pi. 60 pi minus 120 pi divided by 60 pi plus 120 pi. So that would be minus 1 by 3. So now it is coming negative. So now if I need to write down ER, what that would be? So directly it will take care. It will take care on its own. What you need to put? Gamma E into EI. So what I will do? Minus 1 by 3 into tan eta 1 cos omega t plus beta 1z. And don't change this. Direct minus a by cap. Just change you need to do is that this minus 2 plus, nothing else. If this gamma is becoming negative, then you get to know that electric field is changing its direction. And if you write it down, what you get? This minus and minus is getting cancelled. So 10 by 3 eta 1 cos 10 to the power 80 plus beta 1z ay cap. So this was in minus ay, this is in plus ay. So electric field has changed its direction. Okay. And from here if you need to write down your magnetic field, So what you are gonna do? You are gonna divide with the magnitude of, not magnitude, sorry, you are gonna divide with the neta only. So neta and neta will get cancelled because we are in the medium 1 only. So neta 1 only will be divided. So neta 1 will get cancelled. Cos omega t plus beta 1 z. Now tell me one thing, this will be Ax cap only. Why is that so? Without even doing this thing, that your P is equals to E cross H, without even doing this thing, I can tell that it will be Ax cap only. This direction and this direction will be same. How I can tell it? Because electric field has changed its direction. If electric field has changed its direction, then certainly magnetic field will not change its direction, right? Or I can find it from P is equals to E cross H as well. So what do I need to find? AH cap. That will be equals to AP cap cross AE cap. What is my AP cap? My AP cap, in this case, my AP cap is minus AZ cap. And what is my AE cap? AE cap is AY. So what would Z cross Y would give you? Y cross Z would give you X. So Z cross Y would give you minus X. So minus and minus, another plus. So AH cap has become AX cap. So yeah, this is what we are getting. So this has to happen only, no? Because now electric field is changing its direction. If electric field is changing its direction, then certainly magnetic field will not change its direction. Only one of the component will change its direction. Now if I need to find out the transmission coefficient, what that would be? 1 minus 1 by 3. Because what is my transmission coefficient? That is 1 plus gamma E. That would be 1 minus 1 by 3. That would be 2 by 3. So my reflected wave, sorry, not reflected, my transmitted wave which is having electric field component, that would be multiplied with 2 by 3. So this will be multiplied with 2 by 3. So 20 by 3 into neta 1 cos omega will be same only, minus direction of wave propagation will be plus z only, minus beta 2 z, right? And then what I will write? Ax cap, ay cap. What I will write? The same as this, minus ay cap. Minus ay cap, right? This is my Et. And if I need to write down Ht, what I will do? 20 by 3 neta 1 by neta 2 cos omega t minus beta 2z, and what will be the direction? Same as this, which is Ax cap. Or you can find by P is equals to E cross H as well. So by that as well I can find. Do I need to find time average pointing vector as well? Yes. So what will be my Pi? Pi will be 10 by 3 eta 1 whole square divided by 2 eta 1. Direction will be Az cap. What will be my P reflected? That will be gamma square. What is my gamma? Gamma is 1 by 3. Mode of gamma square, 1 by 3 square. So that would be 1 by 9 only. So 1 by 9 times of Pi. 1 by 9 times of mode of Pi, but the direction will be minus Az cap. Is that clear to you? What did I write? 1 by 9 mode of Pi. Magnitude will be 1 by 9 times, but direction will be minus Az cap, right? And what will be your P transmitted? So transmitted will have the same direction. So what I am going to do? 1 minus 1 by 9, or you can write down 8 by 9 of Pi. Is that clear to you? So you cannot write 1 by 9 times of Pi vector. This is wrong. 1 by 9 times of Pi vector. This is wrong. Okay? Wrong. Why is that so? Because direction is different. Direction is different. Wave is propagating in minus z, so here minus Az cap will come. So that is the final answer. So these kind of questions will be asked in your examination if the question is coming from normal incidence. Okay. So again, what is the important conclusion? The important conclusion is, if your electric field is changing its direction, then your magnetic field is not changing its direction. So these are the points which I need to highlight. Ax cap, minus Ay plus Ay. And here what happened? Ax minus Ay. Minus Ay minus Ax. So here electric field did not change. So if your gamma is becoming positive, if your gamma E is positive, then your electric field is not changing its direction. Can I write it down as a statement that if my electrical reflection coefficient is positive, then electric field will not change its direction. incident and reflected electric field will have the same direction. Can I write it down this as a statement? No. Why is that so? Because this formula I calculated neta 2 minus neta 1 divided by neta 2 plus neta 1. This was already an assumption that electric field is not changing its direction. If I had assumed that my electric field is changing its direction and magnetic field is not changing its direction, if I had assumed that electric field is changing its direction and magnetic field is not changing its direction, and then if I had derived this formula, then what will be the answer? Neta 1 minus neta 2 upon neta 1 plus neta 2, then this would be the answer, and here gamma E would become negative. And if gamma E is becoming negative in this case, then you would get to know that actually you assumed the direction will change, but actually it did not change. So these kind of statement you will never find. Neither in your examination they will ask these kind of statement. Why is that so? Because these formula have been derived on the assumption. So do not confuse yourself with all these things. On top level, what you are going to remember? That I have derived the formula assuming that incident and reflective electric field has the same direction. Now, if my gamma is becoming positive, that means my assumption was correct that incident and reflected electric field is having same direction. But if gamma is becoming negative, that means incident and reflected electric field have different directions. Is that clear to you? And if gamma is becoming positive, then incident and reflected electric field has the same direction. Okay. Other thing what you can say, if gamma is positive, that means incident magnetic field and reflected magnetic field have opposite direction. If gamma E is positive, then incident and reflected magnetic field has opposite direction. And if gamma E is negative, that means incident and reflected magnetic field has same direction. Is that clear to you? All these statements, can you resonate with me? If you have listened to my discussion very carefully, if you have solved those two questions very carefully, then you will be able to resonate with my statements. Is that clear to you? And this positive and negative with reference to what? This positive and negative with reference to what? With reference to my assumption. Is that clear to you? Everything you are able to resonate. So from here, what is the conclusion you can make? The conclusion is that your gamma E is equals to minus gamma H. That means what I mean to say is that, or from here you can write down that gamma H is equals to minus gamma E. So if your gamma E is positive, that means electric field will not change its direction. This will be your EI, this will be your ER. So then who has to change the direction? Magnetic field, HI and HR. And how you can confirm it? Because your gamma H is negative. If gamma E is positive, then your gamma H will be what? Negative. And gamma reflection coefficient is negative. That means direction is changed. So this kind of question can come in one of the MSQ, that which of the statement is correct. So this statement is correct. This statement is also correct. 1 plus gamma is equals to tau E. 1 plus gamma E is equals to tau E. So same goes for magnetic field as well. 1 plus gamma H is equals to tau H. Okay. Same goes for magnetic field as well. So what you can write down? Tau H is equals to 1 plus gamma H. And what is your gamma H? Gamma H is equals to minus gamma E. So another formula you are getting, tau H is equals to 1 minus gamma E. You do not need to remember these formulas. These important conclusion I have written only for the MSQ purpose. That in some MSQ, these kind of questions may come up. That they will ask which of the statement is correct. So this phenomena you have understood that why this came. Because one of the electric field or magnetic field will change its direction. If incident and reflected electric field is having the same direction, that means certainly incident and reflected magnetic field will be opposite. And if incident and reflected electric field are opposite, then certainly incident and reflected magnetic field will be in the same direction. So from there we get to know that both of the reflection coefficient will be negative of each other. If one is plus, other one will be minus. 1 plus gamma H is equals to tau H, 1 plus gamma is equals to tau E. So same goes for this, and then gamma H can be replaced with minus gamma E. So this is also one of the formula. Is that clear to you? Okay. So these are the important conclusions. So let's solve some problems now. Let's solve this question. You try to do it on your own. You need to find HI, which is very simple. For HI, what I am gonna do? Divided by neta naught. Neta 1, let's call it neta 1. Cos omega t minus beta z. If this is in AX, this is in AZ. This will be in AY. What about this? 30 sine omega t minus beta z. If this is in Y, this is in Z, then this would be in minus AX. I hope till now you would have the practice of writing it. I am not explaining it. Okay. We have seen these kind of questions a lot of times. So should I explain it? Since it is a recorded video and since it is going on YouTube, so I do not know what is the level of the student, so I will have to explain it. So what I need to do? I just need to divide by neta, right? Because what is my neta? Neta is ES by HS. Since this is a free space, so it will be magnitude of E divided by magnitude of H. Magnitude of E 40 by neta. 40 by neta will be your H. So divided by neta. And how I am writing down the direction? Direction I am writing by P is equals to E cross H. So I need the direction of H. So what I am doing? AP cross AE. AP cross AE. AZ cross AX. What that give me? AY. And AZ cross AY. What that give me? Minus AX. So that I have written. Okay. So this is how I have written HI. If the wave encounters a perfectly conducting plate normal to Z axis. Okay. Normal to the Z axis at Z equals to 0. So this is my plane Z equals to 0. Now this medium is perfect conductor. Perfect conductor. Okay. This is your medium 2. This is my Z equals to 0. This is my medium 2, which is a perfect conductor. Okay. First, most important thing, neta 2. What will be your neta 2? For perfect conductor, sigma is equals to infinity. Perfect conductor, sigma is equals to infinity. So what will be your neta 2? J omega mu upon sigma plus j omega epsilon. If this is infinity, then what will be the answer? 0. So neta 2 will be 0. For a perfect conductor, intrinsic impedance is 0. Okay, very important result. For a perfect conductor, intrinsic impedance is 0. Is that clear to you? You need to find the reflected wave and the reflected wave you need to find, reflected electric field and reflected magnetic field you need to find. So here you are having some neta 1. This is your medium 1, which is having some neta 1, which is equals to 120 pi. So if I need to find the reflected, so what I need to find? Reflection coefficient, gamma I, that is your neta 2 minus neta 1 divided by neta 2 plus neta 1. What is your neta 2? 0 divided by 0 plus neta 1. What is the answer? Minus 1. What do you understand by that? That if there is some perfect conductor, and then there is a wave which is propagating like this. This is the direction of wave propagation. This is the direction of electric field, and this is the direction of your magnetic field. Okay. Is that clear? All are incident. Then after the reflection, what will happen? After the reflection, what will happen is that this direction of after the reflection, this will certainly change. The direction of propagation will certainly change. The direction of magnetic field will not change. The direction of magnetic field will not change, but the direction of electric field will be opposite. Are you able to connect why I am writing down all these things? Because gamma is becoming negative. Gamma E is becoming negative. So what does that mean? That this direction has changed, but this direction did not change. That is as it is. The magnetic field direction is as it is, and this has changed now. And from here, what did you understand? What more did you understand? What more did you understand? I understood that my ER will be same as EI only. Just the difference will be what? The difference will be the direction. Direction will be opposite. Basically, I need to multiply by -1. So by -1, if I multiply, so this will be minus AX cap and this will be minus AY cap, right? So I just need to multiply by -1. So 40 cos omega t minus beta z, 40 cos omega t minus beta z minus ax cap. If I apply minus here, or I can apply minus here as well, minus ax cap plus 30 sin omega t minus beta z, 30 sin omega t minus beta z minus ay cap. This is your ER. Okay. What about HR? What do you think? What about HR? HR will be same as HI. Why is that so? You can calculate it. It will be same as HI. Because this magnitude did not change, this magnitude did not change. Only the direction got changed, no? So what I am gonna write here, 40 by neta cos omega t minus beta z. Then if I calculate the direction, what I am gonna get? Minus ay cap. Sorry, this was, oh sorry, oh sorry, really sorry, this will be plus, no? Why this is plus? Because wave is propagating in minus z direction, so this will be plus. That was a blunder from my side. This will be plus. Okay, so here also this will be plus, this will be plus. So I cannot say HR will be equals to minus HI because the direction has changed, right? But this will be ay cap only. Why it will be ay cap only? Because magnetic field will not change its direction. Plus, what about this? 30 by neta sin omega t plus beta z, then the same direction, which is minus ax cap. Or you can calculate as well. How will you calculate? AH is equals to AP cross AE. So AP cross AE. So minus AZ minus AX. Z cross X would give you minus AZ cross minus AX. So Z cross X would give you Y. And here minus Z cross minus AY. So Z cross Y would give you minus AX. So this is how you can calculate as well. Okay. Again it is giving Y. Yeah. So ER HR we have calculated. What are the total E and H field for Z less than 0? So you just need to add them up. Okay. For Z less than 0, E total is equals to EI plus ER. Total electric field. EI plus ER for Z less than 0. And what is your H total? HI plus HR. And this will make a standing wave pattern, which we will study in the next lecture. Okay. These two combined will make standing wave. These two means these two I am talking about. EI plus ER will make standing wave pattern. So we will study about it in the next lecture. In this lecture, we are not going to study it. Okay. So combined they will make standing wave pattern. Calculate the time average pointing vector for Z less than 0 and Z greater than 0. So fourth one, for Z less than 0. So for Z less than 0, there will be some Pi, right? And there will be some PR as well. What will be your Pi? Pi is 40 square plus 30 square. Orthogonal, they are orthogonal, right? AX cap, AY cap. So they are orthogonal. So I can apply that formula, 40 square plus 30 square. So that would be 40 square plus 30 square divided by 2 neta 1. And what will be the direction? Plus AZ gap, right? I am talking about this is your EI, 40 square plus 30 square divided by 2 neta 1 and then direction of propagation is plus AZ gap. And what about PR? PR will be equals to gamma E square dot Pi. Gamma E square, not dot, sorry, gamma E square into Pi magnitude, but the direction will be minus AZ gap, right? So that would be, this magnitude will be 1 only. So 40 square plus 30 square divided by 2 neta 1 minus AZ gap. So this is your Pi, this is your PR. What they are asking? P total. P total for what? Pi plus PR. P total for Z less than equals to 0. So if I add both of them, what do you get? 0. P total will be 0. If you add both of them, plus Az minus Az, what that would be? 0. Vector summation of both of them, that would be 0. For Z greater than 0, what that would be? P transmitted, Pt I am writing, what that would be? 1 minus gamma mod square Pi, what that would be? 0. And you can say it as well. Why you can say it? Because there is no electric field, there is no magnetic field. In the conducting surface, there is nothing transmitted, nothing got transmitted. All are reflected. Everything is reflected back. So there is nothing in between. Here there is nothing. So certainly there will be no power transmission. Certainly there is no power transmission. So what you can say? This is equals to 0 only. Right? So here total time average Poynting vector is 0. If you ask about incident, that is different. If you ask about reflected, that is different. But both combined is making it 0. And here if you ask about transmitted, so that is completely 0. Is that clear to you? Very easy question it was. We started with Hi, very simply we could find it out. Then medium 1, medium 2. Medium 2 is perfectly conducting. So for that we got to know that our neta 2 is 0. If neta 2 is 0, then my reflection coefficient was minus 1. From here what did I get to know? That if my reflection coefficient is minus 1, that means whatever the wave goes here, the complete wave is coming back. Just that electric field is changing its direction. So electric field change its direction. So if it was going in Ax, Ay, now it is coming in minus Ax and minus Ay. Minus Ax and minus Ay. So I just need to multiply by minus 1. That's it. I just need to multiply my equation by minus 1. I will get this expression by my own. Then I go to know that if electric field has changed its direction, that means magnetic field will not change its direction. So magnetic field is in the same direction as it is. Ay minus Ax. Ay minus Ax. What is the catch only? The difference is this will be plus beta z, this will be plus beta z. Since they are working in negative z direction. So this will be plus beta z. Now you need to find time average Poynting vector. Or third question is for z less than 0, I need to find the total electric field. So both combined, both combined. So just add them up and I can write down the expression. And if I need to write down the time average Poynting vector for z less than 0 and z greater than 0. So for z less than 0, what is my time average Poynting vector? E naught square, that is E naught 1 square plus E naught 2 square divided by 2 neta 1 Az gap. And what will be for the reflected one? The magnitude will be same, just the direction will be opposite. And if I combine them, 0. And for z greater than 0, it is 0 only. Is that clear to you? Yes. Let's solve this question. Medium 1 is air. And if I am making this diagram like this, that means it is normal incidence. Okay. And medium 2 is lossless dielectric. You need to find the time average Poynting vector inside medium 2. The wave in the air has an electric field of 10 volt per meter RMS. So if I am finding Pi, what that would be? Time average Poynting vector. So there is no direction associated. So they will just ask the magnitude. So I am writing down only the magnitude. So what will be my Pi? E naught square by 2 eta 1. 2 eta 1. Where eta 1 is equals to 120 pi. Is that clear to you? Yes, sir. But the thing is, what they have given RMS. Star mark it. What is RMS? E RMS is equals to E naught by root 2. Root 2 of maximum value. Okay, this you need to remember. It is 1 by root 2 of maximum value. This we have studied in network analysis as well, in signal system as well. What is the RMS value? 1 by root 2 of the maximum value. So E naught by root 2 whole square divided by eta 1. So what is the formula you are getting? ERMS square divided by eta 1. So what is my Pi? What is ERMS square? 10 square. That is 100 by 2 eta 1. So what will be your P transmitted? Right? P transmitted. But before that, I need to find gamma E value. So what that would be? Eta 2 minus eta 1 divided by eta 2 plus eta 1. What is my eta 1? Eta 1 is 120 pi. What is your eta 2? Eta 2 is 120 pi. Lossless medium is there. Lossless dielectric is there. Mu r by epsilon r. Mu r by epsilon r. So 100 by 4, 25 and then 5. So it is equals to 5 eta 1 actually. 5 eta 1. So what I can write down? 5 eta 1 minus eta 1 divided by 5 eta 1 plus eta 1, 2 by 3. So gamma is equals to 2 by 3. 2 by 3. So what will it will be? 1 minus 2 by 3 whole square pi magnitude. Okay. So what you are going to get? 4 by 9. So 5 by 9 into 100 by 2 eta 1, that is 125 watt per meter square. So this is your PT, and certainly they are talking about magnitude only because there is no discussion of direction. Is that clear to you? Very easily we found out, right? First we got to know that one interesting thing, that this was RMS. So 100 square by neta, why I wrote 2 here? 100 square by, why I wrote 2? No, 2 will not come. Really sorry for this error. 2 will not come here, right? Because it is ARMS square by neta 1 only. RMS value is 10. So 100 square by neta 1. And what about the transmitted one? 1 minus gamma square. What is the value of gamma? Gamma is 2 by 3. How did you get this value? Very easily, mu r by epsilon r, under root mu r by epsilon r, that is 25. So 5 neta 1. So 4 by 6, 2 by 3. 2 by 3, then just applied the formula 1 minus 2 by 3 whole square. What is that formula? 1 minus gamma square into pi. So 4 by 9, so 5 by 9 into pi. So 100 by 120 pi. Is that clear to you? I need to take a break. Then very easy last question is there. You can try it on your own, just statement based. So, but I need to take a break because I cannot see, like, head is revolving around. So I need to take a break. Then we will solve this question. Very easy. MSQ question it is. You mark the correct statement. Yeah. So let's solve this question. So in this question, your EM wave is traveling from rarer to denser medium. So what do you mean by rarer medium? So air is the rarest medium. What do I mean by that? In air, I can move my hand easily, right? I can move my hand easily. But if I need to move my hand in water, so I will have to apply more force, right? In air, I can move my hand by a minimum force. But if I move my hand in water, then I will have to apply more force, right? So water is the denser medium. There the particles are more close. Here the particles are distributed. But in the water, particles are more close. So what is the quality of a denser medium? That its relative permittivity is more. Epsilon r of denser medium is more than epsilon r of rarer medium. Is that clear to you? Epsilon r of denser medium is more than the epsilon r of denser medium. Okay, because what is the epsilon r of air? That is 1 only, no? Epsilon r of air, or you can say free space. So that is 1. For water, it will be greater than 1. It is, I guess, 1.33. I don't actually remember, but it is 1.33 for water as far as I remember. And for diamond, it is the highest, I guess. I'm not sure about that. I'm just telling whatever that I remember. But for rarer medium, the epsilon r will be less. For denser medium, epsilon r will be more. So this thing you can remember, right? And you must have studied it in your elementary classes as well. So what about neta? What is my neta? Neta is 120 pi mu r by epsilon r. Right? By default, I will take non-magnetic material, so it will be equals to 120 pi divided by under root r. So if divided by under root epsilon r. So if epsilon r is more, that means neta will be less. So neta of denser will be lesser than neta of rarer. Is that clear? Yes. Neta will be less. Now from where to where you are going? You are going from rarer to denser. Rarer to denser you are going. So from medium 1 to medium 2 you are going. Rarer to denser. So this is your medium 2. From medium 1 to medium 2. Rarer to denser. So this is your medium 2. So basically this is my medium 2. So neta 2 is less than neta 1. Now what is my electrical reflection coefficient? Reflection coefficient, that is neta 2 minus neta 1 divided by neta 2 plus neta 1. So what it will become? Since neta 1 is larger, so reflection coefficient will be negative. And if it is negative, what does that mean? That incident and reflected and transmitted. Okay, we are talking about reflected and transmitted. Basically, transmitted and incident both will have the same direction. Transmitted and incident will have the same direction. So you can read this statement in this manner as well. Direction of reflected and incident electric field are same, because transmitted and incident electric field will be same only. So what do you get from here? If gamma is negative, that means electric field direction is getting changed. And if electric field direction is getting changed, that means magnetic field do not need to change its direction. So the direction of reflected and transmitted electric field are opposite, and the direction of reflected and transmitted H field are same, because transmitted and incident will have the same direction. In terms of direction I am writing, will have the same direction, right? Transmitted and incident will have the same direction. The only problem is the reflected one. So now if it is becoming negative, if my reflection coefficient is becoming negative, that means certainly for sure that electric field is changing its direction. That means incident and reflected electric field will have opposite direction. So this and this statement is correct. So that's it. Very easy question it was. So this is the end of one of the most complex topic. But here one more topic we are going to study in this particular chapter only. I should not say chapter, in this particular topic only. That is the concept of standing wave. So first we need to understand what do you mean by standing wave. So if a wave is going, then if it is reflected back, then both of the waves combined make a standing wave. Till now what we are studying? We are studying traveling waves. With respect to time, that wave was traveling. If you remember the diagram of our EM wave. So what was happening? That E and H were dancing, E and H were dancing and wave was traveling, right? E and H were dancing, wave was traveling. Now there will be standing wave. What do you mean by standing wave? What is the concept of standing wave? So that we are going to study. And a very, very important lecture. So that will be very, very important lecture. So that we are going to see in the next video. Is that clear to you? Okay then. So let's meet in the next lecture where there we will build the concept of standing wave. Thank you very much.